Hi, Miss.
Hi,
The
dear.
miss is muted.
I'm here.
Hi, Miss.
Hello, dear.
Hi, Miss.
Hello, honey. So we're letting people in.
Nadim, can you stop asking the question? Stop asking this question, Miss. I mean, Nadim.
Layan, hi, dear. Yes, the
Teachers,
quiz is going to be easy, dear. Don't worry. It is going to be easy.
Oh yeah, we have a quiz today.
Yes, your quiz at 7 today.
Lemon squeezy, and this is
Yeah.
ways.
Your quiz will be at 7 today. Let's take the attendance and start the session. We don't want to waste any time. I think you realized that the homework yesterday was really, really easy, right?
Yes.
The people who did the homework already, you found it easy, right?
Yes. Yes, miss.
Yeah.
Okay.
So easy.
Yes.
But
Yeah.
I just want to say something that I forgot my homework.
Easy
and I'm
peasy,
at my
lemon
grandma.
squeezy.
Okay, if you did not submit, submit it today.
Easy.
Okay.
Please,
Please mute your mics. Mute your mics, please.
I forgot my
Adam,
book
you forgot it where?
at my home, and I am at my grandma.
Oh, all right. Whenever you get your book, please submit the homework, Habiba, so that I can give you the mark. Adam.
Work. Miss.
Yes.
I wanna ask a small question.
What is it?
Whenever Habiba enters the Zoom session, she keeps in the same place that she's sitting in now. So
Ayman, mute your mic, please. Adam, he's not here. Alia, she's not here. Ayman is here. Bilal.
Yes.
Oh, Alia is here. Okay. And Ayman is here. Bilal is here. Dana. Dana is not here. Okay. Habiba is here. Jaida.
Yes, Miss.
Layan is here. Malik. Malik. Cannot see him. Mu'mina is not here. Muhammad Ahmad.
Yes, miss.
Muhammad. Okay. Nadim, he's here. Omar.
yes, miss.
Okay, so Omar is here. Saif.
Yes, Miss.
Suhaila.
Yes, Miss.
And Taim.
Yes, miss.
All right. Malik, I think Malik just got. Malik, are you there? Malik?
Yes.
All right. Okay, guys, we're going to start with the homework correction. I will correct the homework by myself. So please pay attention because I don't want to waste a lot of time correcting the homework. We want to finish the lesson. So I'm just going to do it quickly. So please pay attention. Your homework was page 76, 77, and 78. This is the first page. North end facing south end. The magnets move apart or together. They're going to move together. So this means that they're going to attract. Opposite ends of the magnets attract each other. North end facing north end, the magnets will move apart and the north ends of the magnets will repel each other. South end facing south end, the magnets move apart and the south ends of the magnets repel each other. Okay, so far did you find anything hard? I think all of it is easy, right?
No.
Okay.
Yes.
All right, let's go to the next question. The next question, Muhammad Ahmed, are you raising your hand for a reason?
Answer.
No, I'm going to do the homework by myself because we don't want to waste time. So I'm going to correct it by myself. And then later, if we have any classwork, I'm going to let you answer, okay? North and above north end, please, Ayman. Ayman, guys, do not act like babies. You unmute your mic whenever you want. And now you're annotating my screen. North end above north end and south end above south end, the magnets pulled, it will be pushed apart. So this means that they will repel because the similar ones are facing each other. North end above south end and south end above north end, the magnets pulled together, and the opposite ends of the magnets will attract each other. All right, so this is the homework correction for the first page 76. Now we're going to go to page 77. We're going to pretty much do the same. Look at the pairs of the magnets in the picture. Which pairs will attract each other, which pairs will repel each other, circle your answer. So here, of course, since the two similar poles are facing each other, they're going to repel. Here, the opposite are facing each other, so they're going to attract. Here also, the opposite are facing each other, so they're going to attract. And here, the similar are facing each other, so they are going to repel. What is the next question? The next question is, the ends of a magnet are called poles, the North Pole N and the South Pole S. Do these poles repel or attract? So of course, I'm going to write this. If two North Poles are facing each other, so similar poles repel. Here is the same case. Both South Poles are facing each other, so they're going to repel. And here the North is facing the South, so they are going to attract. Is there anything hard about this? Huh?
No, it is
All right,
good.
it's easy. Okay, let's go to the next page. The next page and the last page in your homework is page 78. It's very easy also. We are talking about that magnets, different magnets have different forces. Some of them are really strong and some of them are mildly or not very strong, and some of them are intermediate strong. So not all of the magnets have the same strength. Not all of the magnets will be able to attract the same number of magnetic materials. Some of them are very strong and others are not that strong. Now let's read the background knowledge first. The most common magnets in a home are used to stick objects to the refrigerator. Magnets come in many different shapes and sizes. For example, some are horseshoe shaped. Others are shaped like rings, bars, discs, and rods. Some magnets pull harder than others. Some special magnets are so strong that they can pick up a car, and we're going to learn about this by the end of the lesson. All magnets can attract things from a distance. But yesterday we made it clear that it is a specific distance. Outside this distance, they will be outside the magnetic field of the magnet and it will not be able to attract it. All right, each of the magnets was dipped into a box of steel paper clips. Place a check mark by the strongest magnet. This is it. This is the whole thing. So what should you do? You will just count the number of the steel paper clips that each one of those magnets have attracted. And the one that attracted the most number is the strongest magnet. This is it. Okay, so let's see the first one. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14. So the first one attracted 14 paper clips. What about this one? 1, 2, 3, 4, 5, 6, 7, 8. So this one attracted 8 paper clips. What about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this one attracted 16 paper clips. And this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. This one attracted 19 paper clip. And what about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It attracted only 10 magnets. So this makes this one, which is this ring magnet, is the forceful magnet. This is the one that is the most powerful. Okay, is it clear for everyone, guys? Huh? Do you have any problems understanding?
I did it right.
All
I
right.
don't have a problem.
All right, very good. Now let's move on with our lesson. Yesterday we stopped at the definition of the magnetic field, and we said that a magnetic field is the area that the magnet is powerful in. As you can see here, the magnet is surrounded by a field, or what we call a magnetic field. And this magnetic field is the area that the magnet can attract anything from it. What does that mean? It means that according to this magnet, for example, the lines around it is the one that is showing a magnetic field, or the area where the magnet is really powerful. So if you have an iron nail right here, the magnet will be able to attract it. If you have it right here, the magnet will be able to attract it. If you have it right here, the magnet will be able to attract it. But if the iron nail is right here, the magnet will not be able to attract it because it is outside its magnetic field, which is the area that the magnet can act on it or can be powerful in. All right, so those lines represent the magnetic field, and you can simply see those lines in real life. Let me show it to you. Just give me 1 second. If you have some iron filings, which is the iron, like iron powder, if you have some iron filings or iron powder and you just sprinkle it on any magnet, it will start to move in a specific way, or organize itself in a specific way that will show you the magnetic field of this magnet, which will show you where is the area that the magnet works in. I'm just getting it to you so that you can see it. Yes, here you go. I'm going to share the screen with you right now. So this is how it looks like, guys. Look at this. Once you put the iron filings on a magnet, it will start to distribute itself in this way. Let's see this picture, for example. As you can see, I don't know if it's, can you see it, guys? Do you see it?
Yes.
Yes. So
Yeah.
you will find that, yes, you will find that most of the iron filings are attracted to the magnet at the poles. The poles have the most amount of iron filings, while the more that you get away from the magnet, you will find that the iron filings are getting even weaker and weaker, attracted to the magnet, until at the end you will find that it's almost not there. Okay, it's almost not there. So this means that this area is the area that the magnet is the strongest in. When you go away from this area, or you get out from this area, the magnet will be weak until it will not have any power at all to attract anything outside of this area. So this is the magnetic field of the magnet. This is where the magnet can attract any magnetic material. Anything outside this area, the magnet will not be able to attract it. Okay, do you get it now? Do you understand?
Yes.
All right. All right. So now we are going to continue. So as I told you guys that the part or the area that has the most or the area in the magnet that is most powerful is always at the two poles. At the people using chat, is there anything wrong, Muhammad? Muhammad Ahmed, you can simply open the Moodle or the Classera and read what you have today in your quiz, okay? Because I have put what are you going to have in the quiz since last week, all right? So you can simply open your Moodle or your Classera last week and you will find the announcement that shows you what exactly should you study. All right, okay. So the magnet is the most powerful at the two poles. At the two poles, the most powerful points of a magnet. This is where all the attraction happens, or most of the attraction happens. The center is not very strong, and of course, the more that you get away from the magnetic field, it's going to be even weaker. Okay. Now, this part is not really important, but I'm going to just say it to you anyway. We say that the magnets have two poles, the south and the north poles. Why did we call them this way? Because they actually represent the south and the north pole of the Earth. The Earth also has south and north pole, of course. So why did we call the south and north pole of a magnet a south and north pole? Because it also represents the south and the north pole. If you have a compass, the south and the north parts of the compass is actually representing or showing the south and the north pole of the Earth. And this is why we call the two poles of the magnet south and north. It's not really important, and you're going to learn about it later in year 6, but it's just like an extra information for you. Okay. Now, what are the magnets made of? Can we make magnets from any metal in the world? Do you think so, guys? Do you think that we can make the magnet from any metal in the world?
No.
No. There are 4 specific metals that we can make magnets from. Only 4 types of metals that we can make magnets from. Can anyone tell me what are those metals? Huh?
Yeah.
Ayman, do you know?
Yeah.
Yeah, can you tell me what are they?
Steel.
Yeah.
And copper.
No, copper is not one of the metals.
No, I don't mean copper. I mean there's something like it called copper or something.
Cobalt. Yes.
Yeah.
So
Cobalt.
yes, steel, cobalt. Yes.
Gold and silver aren't.
Yes. Gold and silver aren't. Yes. Okay, let me continue. All right. So thank you, Ayman. So the 4 main types of metals that make the magnets are iron, nickel, cobalt, and steel, as Ayman said. But steel is a type of iron, and this is why we do not talk about it that much, but we mention it. We mention it, okay? So iron and steel, nickel, and cobalt. Those are the 4 types of metals that can be transformed or can be made into magnets. Okay, they
It
have,
looks like a magnet in.
yeah, they have what we call magnetic properties. What does that mean? It means that we can convert them, or we can make them magnets, because this is something that is one of their properties. Simple, it's like one of their description. They can be made into magnets. So what are the magnetic material? Again, the magnetic materials are iron, steel, nickel, and cobalt. And by the way, they can attract those types also. What does that mean? It means that if you have a magnet, it will attract only iron, steel, nickel, and cobalt. It will not attract any other metal, because there is this wrong conception that magnets can attract any type of metals. This is wrong. Magnet only attract iron or steel or nickel or cobalt. They cannot attract copper. They cannot attract silver. They cannot attract gold. So they only attract those types of materials. So again, what are the non-magnetic materials? As you can see, yes, Ayman.
Miss, I have a magnet, and when I sometimes I make it close to like the bottom that turns on the light, so it attracts to its attracts to it.
You have a what? I'm sorry.
I have a magnet, and when I make it close to the button of the light that turns on the light, it
Yes.
attracts to it.
Well, yeah, because there is a part that is made of iron or steel inside it. So this is why it gets attracted to it.
And also I think it because of the nails. I attracted to the nails.
Oh, okay, okay. So when exactly does this end, this session?
10:20.
10:20. Okay, perfect. All right, guys. So what are the non-magnetic materials, or the materials that cannot be transformed into magnets or be attracted by magnets? Okay, they cannot be made into magnets or even attract magnets, get attracted to magnets. What are those? Copper, gold, silver, of course, the non-metal like leather, wood, rubber, plastic, zinc and brass also. All of those materials are non-magnetic. What does that mean? It means that they will not get attracted to a magnet or be a magnet. It will not get attracted to a magnet or be magnet. Only those four metals are the ones that can be transformed into magnets or be attracted to a magnet. Do you understand, guys?
Yeah, can I just go and say something to my grandma?
Yes, okay. Now I want you guys to open page 79, please.
Okay.
I want you to open page 79, please.
Okay, I opened it.
Okay. This is a simple worksheet. It's very easy. You just have a bunch of materials and you have to tell us whether they are magnetic or non-magnetic. Okay. So let's do this together. Who wants to answer? Who wants to answer? Jaida.
Me, please.
Jaida, okay, I will. Who are you?
I'm Bilal.
Okay, Bilal. I will ask Jaida first and then you're next. Jaida?
Yes.
Okay, Jaida. The copper ion, not cobalt, copper coin, sorry. Copper coin, is it magnetic or non-magnetic?
Copper coin magnetic.
We said that there are only four metals. There are only four metals that gets attracted to a magnet. Is copper one of them, Jaida?
No.
Okay, so it is non-magnetic. All right, it is non-magnetic. All right, now next, Bilal. Yes, Bilal, the silver coin is
Non-magnetic.
non-magnetic. Excellent, thank you. Mu'mina, the pencil is magnetic or non-magnetic?
Non-magnetic.
Non-magnetic, very good. Ayman, Drinks can most probably are made of aluminum. So do you think it's magnetic or non-magnetic?
None.
Non-magnetic, because it's not one of the magnetic materials that we talked about. Okay, what about the paper clip, which is made of steel? Habiba, are you there? Did you come back? Okay, let's take safe. The paper clip, is it magnetic or non-magnetic? It's made of steel.
Magnetic.
Magnetic, excellent, thank you. Okay, I will erase this. Should I erase it?
Yes.
Should I erase it? All right. Okay, so let's go to the next part, which is the spoon and the saucepan lid. Okay, the spoon is also made of steel. Taim, the spoon is also made of steel. Do you think it's going to be attracted to a magnet? Is it a magnetic or a non-magnetic material? Taim?
It's a magnetic.
It is a magnetic material, yes. And last one, the saucepan lid is going to be considered made of glass. Liane, do you think it's magnetic or non-magnetic?
It's non-magnetic.
It's non-magnetic, okay? All right. So the spoon is made of steel, so it is magnetic, and the saucepan lid is made of glass, so it is non-magnetic, of course. All right. Now I want you to open page 80, please. Page 80, please. Okay. Please mute your mics, guys. Mute your mics. Okay. So in page 80, metals can be attractive. Magnets are usually made of the metals iron, steel, and cobalt, and we can add nickel to it. Okay, iron, steel, cobalt, or nickel. So those are only the magnetic materials. We are looking for only those four. We don't, any other metal is non-magnetic. Okay, when a magnet is held near an object made of these metals, iron or steel, the magnet pulls the object toward itself. All right. Now here the science activity. We have two students. Mika said that magnets attract all metals. Raquel said that magnets attract some metals, but not all of them. They did an experiment to find out who was right. Color in each of the metal items that you think will be attracted to the magnet. Okay, I will leave you for 1 minute to answer this one. Okay, I want you to color or maybe circle. You can, if you don't have any colors right now, it's fine. You can circle only the things that will be attracted to a magnet. Okay. So you can do this right now.
Have to.
Okay, dear, you have to wait for us to finish.
Miss,
Okay, and what is the page so I can make it at home?
This is page 80.
8.
80.
Miss, I done.
Okay, dear. Page 80. Okay.
Miss, I have a purple diamond too, not only red.
All right.
All of us know.
And I have two crystals, one dark blue and one light blue.
Okay, honey.
I have two red diamonds and one purple diamond.
All right.
How about this?
Yes, Habiba, please let them concentrate, please.
Okay.
Mute your mics.
Oh, sorry.
All right, shall we start?
Yes.
All right,
Yeah.
Suhaila, what should I, are you there, dear? Suhaila? Suhaila, are you there? Apparently she is not. Malik, are you there?
He is in the Zoom but not talking.
Okay, Malik. I want you to tell me what should I circle. What are the things that will be attracted to the magnet?
The cast iron saucepan,
Okay, the
brass
cast iron
key,
saucepan. And what else?
brass key,
No, we said the brass is not going to be attracted to the magnet. It is not magnetic. Let me show you. Okay, let me show you. Here you go. We said that brass is a non-magnetic material. Okay, so what else?
steel spoon,
Steel spoon. Is there any other thing?
and copper kettle.
No, no. Iron, steel, cobalt, and nickel. Guys, the metal that gets attracted to the magnet is not copper. It's called cobalt. Cobalt. It's other than copper. It's not copper. Okay. Copper is one metal and cobalt is the other metal. Okay. The one that ends with a T is the one that gets attracted to the magnet. Okay. So according to this, Malik, who was right, Mika or Raquel? Mika said that Raquel, yes, Raquel, because she said that only some metals get attracted to the magnets, not all of them. Okay, so the answer is Raquel. All right. Okay, now let's do page 81.
Miss, can I answer?
Who are you?
Nadim.
Yes, Nadim. Okay, we are going to do the next one, which is page 81. Page 81. Okay, it's the same. It's the same. Background knowledge. A magnet is a type of material that pulls on some metal objects. The magnet is said to attract the object. Magnets attract the metals, iron, cobalt, nickel, and steel. Those are only the four that are magnetic, but they do not attract other metals. Magnets can attract or repel, push away another magnet. The force of a magnet can be felt from a distance. For example, an iron nail placed near a magnet will move toward the magnet. It looks, please mute your mics. It looks like magic, but it is just the force of magnetism. Mute your mic. Whose mic is open? Bilal, mute your mic. All right, now Nadim, you can answer. What are the materials? I need you to draw a line, or I will draw the line, but tell me what are the materials that I should match. The what?
A steel
paper clip, yes. So this is the first one.
Pin.
Steel pin, of course. Okay.
Aluminum kitchen foil.
Is the aluminum is one of the magnetic materials?
No, a silver earring.
Is silver one of the magnetic materials? There are only 4 magnetic materials, dear. Steel, iron, cobalt, nickel. Steel, iron, cobalt, nickel. Do you see any of them? Is there any other thing that will be attracted to this magnet?
No.
No, this is it. So the steel paper clip and the steel pin are the only things that will be attracted to the magnet. Okay, guys, I think you have a difficulty understanding. Do you understand what are the magnetic materials?
Yeah.
Yes. Yes. Yes.
Only 4 metals, because you keep answering wrong. Only 4 metals: steel, iron, cobalt, and nickel. Any other material, any other metal or non-metal will not be attracted to a magnet. Only those four: steel, iron, cobalt, and nickel. Okay? All right. Now we have like 2 minutes left. We can actually do pages 82 and 83. So let's do pages 82.
1 minute is left.
Okay. Come on, guys. Open page 82, please. Page 82, please. Okay, choose the correct answer. Which of these objects would be attracted to a magnet? Let's take, some people are raising their hand. Okay, Bilal. Yes, Bilal.
A steel key.
A steel key, very good. Okay, continue, Bilal. A magnet A can hold 3 steel paper clips. Magnet B can hold 5. Which is the strongest?
Magnet B.
Excellent. What about number 8? Magnetism is a type of, is it electricity or gravity or force?
It's now 9:20.
Do you
Is
think?
it electricity?
No, dear. It is a type of force. It's just like gravity and electricity. It is a type of
Miss,
force.
we have a
Yes,
session.
your voice is lagging.
All right. Okay,
Yes,
guys.
your voice is lagging.
Okay, can you hear me now?
Yeah.
Okay, I will end the
Okay.
session. Please check your Moodle and Classera for your homework, okay? You have a homework? Please check
Bye.
Moodle for it. Come on, bye, guys. Bye.